The question is, if A is equal to matrix 0 minus tan alpha by 2 tan alpha by 2 0 and I is the identity matrix of order 2, show that I plus A is equal to I minus A into matrix cos alpha minus sin alpha and cos alpha. So we have to prove LH is equal to RHS. I is given as the identity matrix of order 2 and A is a 2 by 2 matrix. So we have to show LHS equal to RHS. Take LHS. What is LHS? I plus A, isn't it? So just add both the 2 by 2 matrices. I is, we know, we will write 1 0 0 1 plus A is given matrix 0 minus tan alpha by 2 tan alpha by 2 and 0. Just add these two matrices. What we will get? 1 plus 0 gives you 1. 0 plus minus tan alpha by 2 gives you minus tan alpha by 2. 0 plus tan alpha by 2 gives you tan alpha by 2. And 1 plus 0 gives you 1. Okay, so this is our LHS and let it be equation number 1. Again take RHS. What is RHS? RHS is I plus A into, there is a matrix given, cos alpha minus sin alpha and cos alpha. So this is equal to I plus A will be a matrix, isn't it? Sorry, it is not I plus A, it is I minus A. So I minus A will be this identity matrix minus the given matrix. So what will be the value? 1 minus 0 which gives you 1. Again 0 minus tan alpha by 2 which gives you tan alpha by 2. Again 0 minus tan alpha by 2 which is minus tan alpha by 2. And 1 minus 0 which gives you 1. This is just I minus A into, there is one more matrix, cos alpha minus sin alpha and cos alpha. So we have to do the multiplications, usual multiplication like the 7 way. So first column, first row into first column. So 1 into cos alpha is cos alpha plus tan alpha by 2 into sin alpha. That will be the first term. Second term is minus sin alpha plus cos alpha into tan alpha by 2. What about the second row? Second row into first column will be the first element, that is minus tan alpha by 2 into cos alpha plus sin alpha. And last element will be second row into second column, that is minus sin alpha into tan alpha by 2 plus cos alpha. Okay, so we need to prove this is equal to 1 minus tan alpha by 2, tan alpha by 2, 1. So what we will do is, we will put this matrix as equation number 3. Means this equation as equation number 3. We will take term by term. Look at the matrices closely. Cos alpha plus tan alpha by 2 sin alpha is the term here, isn't it? So same term repeats. Same way, cos alpha tan alpha by 2 minus sin alpha, that is the same here also. So again the term repeats. These two terms are the same. These two terms are the same. It is plus sin alpha. So what we have to do is, we have to just calculate, just simplify two values, cos alpha plus tan alpha by 2 into sin alpha and this term. Okay, so what we will do is take the term cos alpha plus tan alpha by 2 into sin alpha. So what we does is, instead of, there are two angles actually in this term. Alpha by 2 is there, alpha is there. So we need to convert it into one of the angle. Then only cancellation happens, isn't it? So what we are trying to do is, we will keep cos alpha as such, plus instead of tan alpha by 2, I am giving the value sin alpha by 2 by cos alpha by 2, because tan alpha is sin alpha by cos alpha, into, instead of sin alpha, we have a formula, sin 2 theta is equal to 2 sin theta cos theta. What happens here? When 2 theta becomes in the question, answer there is only half of 2 theta, that is theta. So here only alpha is there. So half of alpha is alpha by 2. So what we get is 2 into sin alpha by 2 into cos alpha by 2. So cos alpha by 2 gets cancelled. So what is the value we are getting? Cos alpha plus 2 sin square alpha by 2. So that again we have a formula. What's the formula? 2 sin square alpha is equal to 1 minus cos 2 alpha. So here also, when alpha is there in the question, double the angle will be in the answer. 1 minus cos 2 alpha gives the value 2 sin square alpha. So here already the angle is alpha by 2. Its double will be alpha by 2 into 2, which gives you alpha. So if you are applying this formula for this term, what we will get is cos alpha plus 1 minus cos alpha, isn't it? So minus cos alpha and plus cos alpha gets cancelled, giving you the value 1. So we have simplified the first term. Take the next term. Next term is minus sin alpha plus cos alpha into tan alpha by 2. So we are going to take that minus sin alpha plus cos alpha into tan alpha by 2. So what we are going to do is minus sin alpha plus, minus alpha into 1. Why we are taking 1 as instead of 1 we have to apply some other value, plus cos alpha into tan alpha by 2. And instead of 1 minus sin alpha into, I can write as cot alpha by 2 into tan alpha by 2. Why? Because tan and cot are reciprocals of each other, plus cos alpha into tan alpha by 2, isn't it? Again, what is common for these two terms? The common term is tan alpha by 2. Take it common. What is the balance? Minus sin alpha into cot alpha by 2 plus cos alpha. Okay, so that is equal to tan alpha by 2 into minus sin alpha. Instead of minus sin alpha, give the same formula which we gave for the first part. That is 2 sin alpha by 2 into cos alpha by 2 into, instead of cot alpha by 2, we can write cos alpha by 2 by sin alpha by 2 plus cos alpha. Okay, again sin alpha by 2 gets cancelled, giving you tan alpha by 2 into minus 2 cos square alpha by 2 plus cos alpha. Again tan alpha by 2 into minus of, we have again a formula, 2 cos square theta is 1 plus cos 2 theta. Okay, so if we apply negative, I took it. So instead of 2 cos square alpha, if we apply this value, what will be the value? 1 plus cos alpha plus cos alpha, this term. So open the bracket, tan alpha by 2 into minus 1 minus cos alpha plus cos alpha. So cos alpha get cancelled, minus 1 into tan alpha by 2 gives you minus tan alpha by 2. Okay, so take the second equation once again. So we have simplified both the required terms. So take the second equation. Second equation what was? I minus a into cos alpha into minus sin alpha into cos alpha, and we got the value as cos alpha plus tan alpha by 2 into sin alpha, and the second term is minus sin alpha plus cos alpha into tan alpha by 2. Again second row, minus tan alpha by 2 into cos alpha plus sin alpha, and here it is sin alpha tan alpha by 2 plus cos alpha. Okay, so this term cos alpha plus tan alpha by 2 sin alpha, we got the value as 1. So instead of the first term, we can replace by 1. Minus sin alpha plus cos alpha tan alpha by 2, that was the value we took for simplification in the second case, and we got the value as minus tan alpha by 2. Okay, these two terms are the same. So here terms are the same, but there is a change in the sign. So here cos alpha tan alpha by 2 is positive, here it is negative. Sin alpha here is negative, here it is positive. So the value for this term is minus tan alpha by 2, and this term is the negative of this term. Okay, this term is the negative of this one. So the value of this term will be minus of minus tan alpha by 2, which gives you minus of minus tan alpha by 2, which is tan alpha by 2, and these two terms are the same, so giving you the value 1. So the answer is 1 minus tan alpha by 2, tan alpha by 2, and 1. Let this be our equation number 2. Why I put 2 is because for this equation I already put number 3, and for this one I gave equation number 1. Again compare equation number 1 was our LHS. We got 1 minus tan alpha by 2, tan alpha by 2, and 1. And here when we took RHS also is 1 minus tan alpha by 2, tan alpha by 2, 1. So the answer is LHS equal to RHS, hence proved.